if a team of 30 undergraduate students can put this Hyperloop pod together, I don't see why we cannot put a spacecraft together, because there's more guidance around it. There's more people that can tell us what to do, what not to do. There's more written stuff around it. There seemed to be a very clear gap that, yes, there's so many satellites up there, but they don't cover the spectral range that one needs. And hyperspectral seemed like a gap, and just want to build and send stuff to space. And that's what we also wanted to do. And the idea for Pixxel started to turn into a little bit more concrete in its shape.
Meet Awais Ahmed. Awais is the CEO and co-founder of Pixxel, which is a hyperspectral imaging startup located in India's startup capital, Bangalore. At Pixxel, Awais and his team are designing and building the world's highest resolution hyperspectral imaging satellites to provide critical insights for monitoring and protecting the Earth. Here's a quick primer. Satellites image the Earth in a few different ways. Most people associate satellite imagery with what you see on satellite view in Google Maps. These images are taken with the 7 primary color bands of light, also known as the visible spectrum. But Pixxel's hyperspectral technology offers a significant leap in analyzing the Earth in over 250 different spectral bands. And here's why that matters. The more bands you can capture and image in, the more information you can extract about the target area imaged by the satellite. And with more information, we can generate deeper, more granular, and actionable insights from the image. Pixxel aims to use this detailed information to generate insights about the health and composition of the Earth's surface, as well as support decision-making in agriculture, energy, mining, and more. In this episode, Awais and I cover many topics. We chat about his early experience building India's first Hyperloop team and how that led to the creation of Pixxel with his co-founder, Kshitij Khandelwal. We also talk about the space startup environment in India, the importance of scale, and how India's cost-effective environment has enabled Pixxel to thrive with limited funding. I loved this chat with Awais, and it was extra special to talk to a founder from Namma Bengaluru. And as a reminder, if you're enjoying these episodes, make sure you hit like and subscribe to the pod so you can stay tuned for future episodes. Now, on to the show. When I first learned about Pixxel, I was excited that it was a Bangalore company, right? And I think I've mentioned to you before, I'm from Bangalore. I grew up there for 18 years. So at the top of it, I was very excited to see a company from Bangalore, but I was even more surprised to see that the company was in the US as well. And so that I think that was it was very exciting to see Pixxel already become global. Was that an intentional decision from the beginning?
It was, yeah. I mean, I think space by design has to be global. Your customers are global. I don't think it's necessary for US companies to be global. The market here is big enough, but for anyone else building in the world, I mean, you cannot not be in the US. So it was quite a conscious decision from day one, in fact, pre-day one, day zero, that we have to have a presence in the US. We need to work very closely with partners and government and the customers here, while not ignoring or compromising on the commercial market that exists in Europe, in Asia, and the rest of the world. So from day zero, we have kind of been a US-Indo company, trying to balance and work on opposite sides of the globe.
Yeah, it's very exciting to see a really global company from India. And we'll talk more about the Indian space market. I'm really excited to get your thoughts on it. But the first question I have for you is that you are an avid reader and you clearly have a big bookshelf behind you. What are you reading right now?
Oh, right now, I just started reading this book called Shogun. I think recently a TV show was also made about it, but I generally tend to read the book. So I just finished reading this book called Cloud Atlas, and I started reading Shogun.
What's Shogun about?
So it's basically historical fiction, set sometime in, I think, the 18th or the 19th century. This was when the Spanish, the Dutch, the English were all trying to send their ships out and colonize the New World and the East. So the story begins with this one English pilot, and by pilot I mean a ship pilot, who ends up being shipwrecked and ends up in Japan for the first time. And from there, he I think goes on to become a crucial part of the Japanese kingdom and sort of everything else. So there's a lot of samurais and other things. So I was told that it had one of the most epic stories of all time, sort of comparable to or close to the Count of Monte Cristo type story. So I just thought, why not pick it up and see where that goes.
Yeah, that's really cool. I love your all your reading recommendations on Twitter are so diverse in nature. They're not just space flight related, or they're not just technology related. They're very diverse, and it's really cool. Thanks for sharing that. You when you grew up though, when you grew up in India. You grew up in Chikmagalur, right?
That's right.
And I know where that is. Maybe some people in our audience know where that is. It's a small little rural town in Western Karnataka, right? Tell me a little bit about your upbringing there. What was it like growing up in Chikmagalur?
It was very idyllic, but it was also very cut off and secluded, which is good and bad in its own ways. But I think overall, leans on the side of being a very positive experience. So I grew up in a village that's about half an hour away from the town of Chikmagalur. So the town of Chikmagalur itself is fairly small. It's known for its coffee plantations and it's considered a hill station getaway. But where I grew up was about 20 kilometers further away from the town. And so growing up there until I would probably say my ninth grade or 10th grade, that was all the world that there was for me, right? You grow up, studying there, you go to school, you come back, you play with your friends, you do your homework, you repeat. Um, I didn't really know the scope or the scale of the world that existed beyond it. And uh, that started to change, I think, when the internet started to open up. And I remember the first time when I got to sort of, explore the internet was in the eighth grade, which was already kind of a little too late. And then things started opening up. Um, but it was still quite secluded. Then for my 11th, I ended up going from Chikmagalur to Mangalore, which is on the western coast of Karnataka and India. And that's where I think the rest of the world started seeping in. I got to know that there are these institutes called IITs, Indian Institute of Technologies, which are the prime institutes in the country that everyone wanting to do something good and wants to get into and so on. And usually people, as you know, start readying for it in eighth grade or ninth grade. And so it was already kind of late as I was entering 12th grade to do that. But I think growing up there was overall positive because I think the weather's great. The beauty of the location is pretty good. We ended up trekking or hiking in the weekend, not because we wanted to go trekking or hiking. It was just sort of how that was. But I think it helps you sort of stay close to the ground as you sort of grow as well. So I think that was how that was.
Yeah, I draw a parallel to what you're just describing to how I grew up too. I mean, I grew up in Bangalore uh, for about 18 years, and all I remember was like playing gully cricket, eating chaat, going to school and coming back until the internet came about, which I think for me was about fifth grade. I would like to remember, if I remember correctly. And my first exposure to a computer was not actually the internet. It was actually playing games on the computer, like Need for Speed and Dave and all of these games that were out in the US.
Had Prince of Persia.
Prince of Persia, yeah, that's a great one. Counter Strike, oh gosh, brings back a lot of positive memories, like you say. And that was the first time I sort of realized, like, there's this machine that you can just any regular person can write a program and build things with. So you went to Mangalore, and I have to say, right, like IITs are so tough. There's so many documentaries that's been made on it. It's a very prestigious institution to get into. I certainly tried, and I did not rank well enough to be considered there. But it's amazing how well-rounded that education is in India. And so you went to BITS Pilani, though, which is also a very prestigious institution. in the BITS circuit, like BITS Pilani Goa, and I can't remember the other one. But what was the experience like in BITS for you?
Well, I think still are, right? That's where you got to live the college life that you see about in the movies and read about in books and all of that. But um, it was really formative for me because I think you have the cream of the nation coming together in a few of these institutes, right? If you look at the top 10 institutes, seven of them are the IITs, and you would have a couple of the BITS institutes in there in the Pilani campus and others, and then you would have maybe one or two others. Um, and in these institutes, you kind of, in a country of more than a billion people, you end up after a very competitive exam, all these you know overachievers already at that age who have done so much, who've built so much, and you kind of get a little bit of an imposter syndrome just hanging around with these folks, right? People that are not only studying well, but for example, might be really good at guitar, or someone that's played national level chess or something else, and then you're like, oh shit, what was I doing in my life? And I think that's looking back, a feeling that most of the folks would sort of end up being there. And but what that does is it's not a bad thing. It actually helps push you to do something better, push you to find your own niche and do something good as well. The higher the bar of the people around you, the higher that you get to sort of aim as well. And I think which is what happened in my case. Obviously, we had a lot of fun. BITS is one of the only institutes in the country where there's no mandatory attendance for writing an exam. All the other institutes in India, you have to have 80 or 90% of your attendance over the year for you to even write the final exams, which is not something that you have in the US, right? So it might come as a surprise, but BITS is the only institute where you don't have to do that. And so I definitely made full use of that by not going to the classes as much as I generally should have starting in my second year. But what that allows you is, this is an institute right in the middle of a desert. So there's not really like a city that you can go out to and explore or go pubbing and things like that. So you have to figure out things to do by yourself. And so if you're not studying, you're either, going to a couple of bars or drinking, which quite a few folks do, or you figure out some other interesting cool stuff to do, which is what I ended up doing in my first and second year. I ended up being a part of this student satellite team, and the first time I entered college, and got to know that there are so many different teams doing so many cool kinds of things. Someone's building a humanoid robot, someone else is trying to build a Formula student car, someone else is trying to build a satellite. That love for space, ever since I was a kid, was like, I got to be a part of this team. And you have to then write a test and go through an entire series of uh, adventures to get into the team. And once I got in, I think I spent more time learning and contributing there than I did going to classes, or personally would have learned in classes as well. And then my second and third year became a part of the Hyperloop India team, and ended up leading a bunch of the engineering there as well. So I would say it was just hanging around with these people who also had the same aspirations, who would not scoff at you if you said, "Come, let's go build a Hyperloop pod and compete in the SpaceX competition, because we might get a small chance to meet Elon Musk," or let's figure out how, as students, we can build and launch a satellite that ISRO might help launch for free as part of their student satellite program. So I think the place taught me to dream bigger than I think most people sort of end up doing in their own lives, and I'm sort of grateful to that. And yeah, I think that friends you make there, and the fact that you really don't have a lot else to do outside just focuses you to do something productive and worthwhile. So it was, I would say, yeah, very very formative 4 years of my life at BITS.
I want to talk about Hyperloop and I want to talk about the student satellite team, but I heard something interesting saying a lot of entrepreneurs and founders talk about this a lot, which is the imposter syndrome that you mentioned. How do you deal with it? I definitely deal with it from time to time, whether it's at work or whether it's different endeavors I'm trying to do. How do you deal with it? I'm just curious.
Yeah, I mean, I think for me it's kind of like an inbuilt mechanism of how I respond to it. Like I respond to most other problems, but in the end, if you look at the imposter syndrome, when you're feeling that, I think there's only two ways, right? You can either wallow in self pity and be like, shit, I'll never do what these folks have done, and what have I done, and that leads you to a little bit of a spiral where you become unproductive, and there's no point in that, right? There's no point in that. Um, or you can, on the other side, be like, what, I think if this person can do it, maybe I can also do something worthwhile, and let me sit down, figure out what to do, and sort of get going at it. And that second is the response that naturally comes to mind whenever I look at someone that has done something really good at a young age, or at any age for that matter. It's like, wow, that's very cool, and I'm happy for that person. But also, I need to hunker down and sort of get moving, because I think the bar has been raised higher. And if that person can do it, I don't see why I myself can't, right? So I would say that kind of is a small surge of motivation at that point in time, and that builds the momentum for you to do things. So I would say that's kind of how I dealt with it. Of course, I think people can also figure out how to be content where they are, but if you're content in the first place, I don't think you would get the the feeling of the imposter syndrome. So I would say you can either feel sad about it and sort of let it go, or you can take action, and any action is better than no action. So I tend to bias on the side of let me sit down and do something that can sort of raise the bar.
Yeah, I find that when you also are around people who, um, like you said, you surrounded yourself with a lot of people who are also building and who are also like the cream of the crop. And I tend to find that when you're around people, they tend to lift all boats, as a rising tide lifts all boats, I guess. So it's very cool. So what was first? Was it the satellite team that you joined first, or was it Hyperloop?
Yeah. In my second semester till my, I think, sixth semester, it was the student team, and then I think around the fifth or sixth semester is when the Hyperloop thing started. So the satellite team came first.
Okay, so what prior to joining the satellite team, what was your exposure to building spaceflight hardware? I'm assuming low to none, but I'm curious, how did that shape you through 4 semesters? How did you what was the caliber of building the satellite? Did you go through things like thermal testing, vibration testing? Was that part of the consideration, or was it more along like, let's get this thing built because it needs to launch on a PSLV in the next year?
Yeah, I think the student team was more about learning than it was about a particular timeline or launching at a certain schedule, right? Which is what most startups, including Pixxel, sort of do today. The focus with the student team, it was called Team Anant, was basically that let's bring a bunch of students together, let them learn in practical terms what it takes to build hardware like this, and then end up launching it. And the learning part was quite important. There was no rush on the schedule. It was more about getting together the smartest folks that have applied from a particular batch, selecting them through a series of successive tests, and then saying, look, here's study material, go study and go figure out how to do things. Right, for example, we got to prototype a bunch of the electronic boards and the structure and the antennas and the testing with the communication and the radios that you could do. Or being able to build Helmholtz gauge. How do you simulate the magnetic field that's in orbit once a satellite goes up there? You build a Helmholtz gauge that can simulate that, right? So going about building a Helmholtz gauge and sort of designing that from scratch. In a startup, usually one would end up buying a Helmholtz gauge because someone's already done it. But in the case of the team, it was the whole point was to learn the physical concepts, how that leads to engineering, and how to actually manufacture and build it and sort of test it out with that. So I think the entire process of getting into the team itself was, I think, a 6-month process, which was in the first semester you have to write a test, which is basically an aptitude test, which just checks for probably reduces the number of students that have applied from 200 to probably 20. And then from there, you go through a series of interviews, and then you're given studying material for a duration of about 3 months, where you have to study. And then at the end of 3 months, you're evaluated again on actual satellite knowledge. And then you become a part of the team. Until then, you are just still
Wow.
prospectively looking at getting in. So that taught me quite a bit that, wow, these folks think a little bit differently. And like these folks that are 2 years from me who know so much about satellites went through the same process that I did, which means they also had zero knowledge of satellites like I did. I had zero knowledge of building anything space related up until then. But once you get that hang in life for the first time, that hey, I don't need anyone to teach me, I don't need a teacher, I don't need someone to show me, I can actually pick up books, textbooks, I can go look up on the internet, and I can figure out how to do things by myself. I think that's when an entirely new world opens up for you, where almost nothing can stop you from building anything that you want within reasonable bounds. So I would say that was quite formative. And in the 4 semesters, I personally got to work on the GNC, the guidance, navigation, and control subsystem of the satellite. And as part of testing that, designing a Helmholtz cage and sort of realizing how that will come together and how should we test the CubeSat, the 3U CubeSat that we would build. Of course, it didn't end up launching in that period because, as I mentioned, there was no schedule to build something and put it up there. It was about, can we teach these folks to learn and think for themselves, which I think was the biggest learning that came out of that.
So it's a 3U CubeSat with, I'm guessing, like just simple deployable panels on either corners with three triple junction cells.
Yeah.
Um,
Yeah. So
and
that was a very basic 3U CubeSat at
yeah.
the college. Yeah.
And do you achieve attitude control with magnetorquers or?
Magnetorquers, reaction wheels.
Okay. Yeah, and that's similar to what you use in Pixxel today, right?
Yeah, different scale and different levels of control and stability required, but the basic concepts are the same. Yes.
Yeah, that's incredible. So yeah, that that it's I say that because a lot of what you've already done in school, getting it exposure to building a satellite. We say space is hard, but like at least having that exposure in school to building a satellite really helps you get there a little faster, hopefully. I myself was involved when I was at USC. I was involved at USC's well, actually, we it was a bunch of grad students, 5 of us. We got together and we decided to found a liquid propulsion lab. So we wanted to test liquid rocket engines. SpaceX was down the road from us, and all of us were certainly fanboys of SpaceX and wanted to be part of the SpaceX mission. And we were trying to pick up different subsystems that we wanted to work on. And the easiest one that felt most exciting was certainly not easy. Felt most exciting was shooting fire out of the back of a rocket engine. And so we got together and founded this lab. But it was very humbling to learn how difficult it is to get a liquid engine to fire. There was already a group working on solid rocket engines. And solid rockets are a little simpler in that respect, but
Yeah.
the complexity certainly helped shape a lot of us who went on to go. I worked at SpaceX, a couple other people worked at SpaceX, and then we all worked on in the industry now, and that's certainly helped shape us. So that's really cool to hear that these important institutions in India, the BITS, the IITs, have this program, and it's exciting to see a lot of the talent that will come out of there. How did your experience in the satellite group translate into Hyperloop? And talk about that journey a little bit.
Yeah, that was also quite serendipitous. I happened to walk into the room of a senior to talk about something else, and I saw his roommate scribbling something about the Hyperloop on the whiteboard. And then most of us obviously followed Elon Musk at that point in time, given what he had done with SpaceX and Tesla in 2016, 2017 as well. And then we got to talking about the Hyperloop, and I realized this is 1 year senior of mine at college was looking at participating in the SpaceX Hyperloop competition, and I'm like, you know what, I'd like to sort of join in and do this as well. And so, given I was the junior, I was in charge of the menial tasks to start with, putting up posters across the campus and conducting tests to hire more people and all of that. But eventually, I think from a student team that had the goal of thinking of designing a Hyperloop pod, we never really seriously thought at that point in time that we would get through even the first stage. The idea was this might be a small teeny tiny chance to go meet Elon, and then we'll see how and what comes off that. But then once we submitted the first design, which we obviously thought through as much as we could during the second year of college, and what you learn from that point, and then we had to take it a lot more seriously because there were 2 more stages: a preliminary design stage and then a critical design review stage, where you had to build successively deeper and more detailed models with simulations as to how the pod will perform, and then manufacture it. And so we kept getting through those stages, and the learning from Team Anant that all you need is a basic guideline of what the physics are, and then from there you build it up to realize how can you use existing engineering materials to manufacture something, and then from there to actually building and manufacturing something. So we ended up splitting the team into basically 3 big sections. You had the mechanical and the structural team responsible for the structure. You had the avionics and the software team for everything that sort of runs the brain of what the pod needs to do. And then there was a dynamics team, which is to make sure that it was stable, that it could accelerate, levitate, and brake. And that's where sort of I was leading the charge around, building the entire levitation and things like that. And to give you a little bit of sense of how new and novel it was, no one had really built something that could reasonably levitate any vehicle with just passive magnets. You have maglev and other things which is actively super cooled magnets and stuff like that that sort of does that. But what about using passive magnets to do that? There was a paper that NASA had come out with, I think Lawrence Livermore National Lab, in conjunction with NASA, around a potential launching mechanism using an induct track. It's called an induct track, where you use passive magnets with an aluminum track to
I think it's
shoot,
called a railgun. Is
kind
that?
of like a railgun, shooting
Yeah.
stuff into space. I don't think that obviously works from Earth, but if you're trying to do it from the moon because of no atmosphere, it's a really cool way to send lots of stuff into orbit. And so that was the place that we found that there was some guidelines around how do you build this thing called a Hallback array for magnets and stuff like that. So I looked at that and I'm like, okay, shit, now we need to sort of design this. And then we ended up getting the Maxwell software suite for free for the competition, and all of that I had to learn from scratch. Right, there was no professor teaching me this is how you use this or this is how you go about it. That was the place that probably taught me the most about agency and self initiative. No one's going to come and teach you. You just have to, this is the outcome, this is where you are. You need to figure out what steps there are to sort of get there. And we managed to build the Hyperloop pod in a span of 3 months during the summer holidays, because that's what we all decided to. A bunch of about 30 students came down to Bangalore, because you couldn't build that in the middle of a desert in Pilani where we were studying. But in Bangalore, we were able to, in a span of 3 months, put it together. At least 80% of it, we packed it up, we shipped it to Los Angeles. There was a lot of issues around customs and things like that, because the magnets are really powerful and considered hazardous material in planes. And then we had to figure out how to put the rest of the pod together in Los Angeles and go compete at the SpaceX competition at their headquarters. So I think that was the experience that taught me the most about how not only complex engineering works. How do you need to look at trade-offs? How do you need to design something from scratch and something that no one has built before? But also how teams work. How do you make sure that teams can work together and collaborate across different time zones, across different campuses, and across different kinds of multidisciplinary domains? It was. I remember sitting in Bangalore at the workshop where we were putting it together, that I started thinking about, hey, I think after the Hyperloop thing is done, I want to sort of focus on building a new team for space technology. If a team of 30 undergraduate students can put this Hyperloop pod together, I don't see why we cannot put a spacecraft together, because there's more guidance around it. There's more people that can tell us what to do, what not to do. There's more written stuff around it. At least 100 times more than what was available on the Hyperloop. And so I think that was quite crucial. We got to meet Elon. I got to shake hands with him, take a selfie with him. But most importantly, it was learning over the course of that 1 year that we worked on building something completely new, novel, and unique.
Yeah, that's such an excellent point that I didn't even think about the logistics of getting high strength, I'm assuming rare earth metal magnets on an airplane where you don't want to interfere with the navigation equipment of the airplane itself,
Correct. Yeah.
and getting it to LA and through US Customs and Border Patrol. And
Yeah.
that's that's incredible. And it teaches you that um, running a company with complex hardware that has to be assembled in different places needs a lot of like federal regulatory approvals, a lot of like paperwork that needs to be done. And that often times, in my opinion, can take down a startup that, say, is trying to generate revenue. And it's a great learning lesson. It's great to do it through a student competition, where arguably the stakes are a little lower than running a company like Pixxel, which is great. That's what we're going to talk about now. Is you talked about the genesis of the idea of Pixxel was during the days of Hyperloop, where you realized we can do this, we can build this. But before you uh, before you went off and built the company, talk to me about what was the what was the atmosphere in India for a space startup? Because prior to Pixxel and Dhruva and a couple of other companies that I have come across now, I had not heard much about space startups coming up in India. What was the atmosphere like, whether it's in Bangalore, which is a big space hub in India, or any of the other big cities in India? What was the sentiment around that?
So I think the sentiment was getting positive mainly because of the success stories that we had seen coming out globally, right? SpaceX had done so well, and it was, I think, the first 5 or 6 continuous years of good execution that SpaceX had in terms of it being globally recognized. And before that, it was always like, will it survive, will it not? Even though they had ended up launching in the late 2000s. 2016, 2017, I think everyone had realized that SpaceX actually came in and disrupted stuff. And that was, I think, seeping in. And it was not only them. Planet Labs had launched, hundreds of satellites by then. You had the likes of Spire Global, also launched, I think, tens of satellites, if not hundreds, to sort of look at weather. So a lot of these companies were coming out, and Firefly Aerospace trying to build rockets, Relativity Space. So I think in the space bubble, if I were to say, people who knew what was happening in space, it was quite optimistic that we are in that second renaissance for space, and hopefully we will sort of end up not stopping this time and growing an in-space economy. But that was within the space bubble. If you looked at the overall, I think, broader context in India, people didn't really know that an ecosystem like that even existed. No one really cared about it. The government didn't really pay particular attention to it. ISRO, the Indian Space Agency, was continuing to do what it was doing. It was obviously a matter of pride for everyone that they kept on doing the things that they did with the budget that they had, and so on. But no one was really particularly interested or even cared about the fact that how many private space companies are there. Do they have challenges? Because there was not even a policy or a law or regulations in place for a private space company in this was 2018, 2019. And so after coming back from SpaceX, looking at the SpaceX headquarters, the rockets and all of that, is when I started diving deep. And after sort of looking at asteroid mining and in-space manufacturing and hyperspectral imaging, I think there seemed to be a very clear gap that yes, there's so many satellites up there, but they don't cover the spectral range that one needs, and hyperspectral seemed like a gap. And that's when I talked to Kshitij, my co-founder, because we used to play FIFA together, that I've been thinking about this for the past few months, and here's a rough plan of a constellation that we will launch as step 1. Step 2, we will send these out to other planetary bodies, and step 3 and step 4 and so on. And so I think the fact that we knew each other well because we used to play video games together and sort of just hung out at college gave us the comfort to sort of then dive deeper in 2019. But the entire second half of 2018, I was just spending sort of thinking about it. And that was because, as I said, one, there was this optimism globally about private space companies can also do stuff. It doesn't have to be restricted to space agencies. And second was, there were a couple of inspirations in the country also. The primary that comes into the picture is this team called Team Indus. I don't think most people know about them anymore, even in India, but they were one of the 5 semi-finalist teams of the Google Lunar X Prize. So X Prize had come up with this competition to build a lunar lander, a rover, land it, and rove a rover for I think 100 meters or so. It was successfully win probably $25 million worth of a prize money, and Google was sponsoring that. And they were leading for quite a while, but they couldn't end up raising enough money to launch the lunar lander to the moon. It's an expensive proposition. I think you would need $50 to $100 million on the lower side to be able to do that. Just booking a rocket that can sort of go there, even if the lander and the rover is small. And they didn't have lunar ride shares at that point in time. Nowadays, you can probably even get lunar ride shares. You have space tugs that can get you there, but that wasn't the case, obviously, in 2015, 2016. So they were a little early. And I'd seen them, and I'm like, wow, private companies trying to actually land a lander and rover on the moon. So that was the situation when Pixxel officially started. But before us, there were about 3 or 4 companies that had started on that path. One was Skyroot, Agnikul. I think both of them had started in either late 2017 or early 2018. Dhruva had been at it since 2014, but they were basically dormant for a couple of years before they rekindled in 2018 again. But it was a handful of companies. It was probably just these 5 or 6 companies that were starting to do someone. No one had built something. No one was closing to launch anything. No one was close to launch anything. No one had raised decent amounts of money. But the optimism was very high. People just want to build and send stuff to space, and that's what we also wanted to do. And the idea for Pixxel started to turn into a little bit more concrete in its shape.
Yeah, the problem thesis is very clear for Pixxel, right? There's all of these satellites. Some of them are imaging in the visible spectrum. Folks like Umbra are imaging in SAR. And you've talked a lot about how SAR and Hyperspectral are complementary data sets. So that's a very nice fit into this market, especially for a country like India, where projects like land use and concerns like pollution monitoring, these are all classic applications that Hyperspectral can tackle. But you said that the revisit rate was low, right? So that's when we started Pixxel. You've launched 2 satellites
Three.
so far. Three, and most recently on Transporter 10, or
The most recent one was in November of 2022. So it's been some time since we have launched satellites, but that's going to change soon. But we put up two in 22 and one in 21.
and then Shakuntala. Those are Shakuntala, Anand, and what is the third one?
That was just like a demo. We didn't really name it anything cool. It was just like demo.
Okay, so Shakuntala and Anand were 150 bands at a 10 meter, and what was the revisit rate on that?
That was limited by the orbit, right? You had about a 30-kilometer swath on those, and they would come back and revisit places every 8 to 12 days in the equator.
Okay, and it was
it gets better as you go towards the poles. Like you could probably come and look at things every day or every 2 days the closer you are to the pole, but it's worse near the equator, which is where it was probably between 8 to 12 days in most cases.
And it was on a sun synchronous polar orbit.
Correct.
Okay, great. So I want to talk about Anand, right? I think that was the first in line, and you mentioned that recently on a blog post. You mentioned that there were several lessons learned about component qualification failures. Can you talk a little bit about that? What happened there? And I'm just very curious about learning about failures.
Yeah. I think that was the first satellite we started building. That was the last that ended up going out of the 3 demos. And the other 2 demos actually got built after that. That was also because I think, look, we were 4 students when we started, and we had raised less than $1 million in pre-seed booking, pre-seed funding at that point in time, which was barely enough for one satellite if we were really, really efficient with the money and we spent on nothing else. And we got started on that. But then due to the limitations we had to work with a few partners in India. And they did have some experience of working with ISRO, but in the end, ISRO was the one that put things together as a system. So these folks didn't really have a sense of how things would need to work from a long-term standpoint. And so we were initially supposed to launch it in February of 2021, which was when the first satellite of us would have launched. But we had to pull out 14 days before launch because we realized that this vendor that we were working with had told us that, oh, this works, this functionality is check. And you would generally assume in the space sector, when people give that, they've tested it. Not so in this case. We realized while we were doing final checks at the last moment before sending it out as a system, because that is only when it all came together that, oh, these things don't work. 90% of what they had said isn't working. And we had to pull out at that point in time, which was a big bummer, obviously. And then we had raised our seed round of about 8 million by then. And so we said, look, we don't want to put all our eggs in the same basket. So we will build one more demo. And so we'll make sure that there's a decent number of iterations and also demos that can show that at least even if one of them work, we're good. We have proved that we can build and launch it, and Hyperspectral can work from space. But with Anand, it was, when we realized that 60% of this doesn't work, we had to redo that entire thing. And that's a very expensive proposition. So we realized how important following at least some semblance of, going through requirements and making sure that everyone's following the same requirements to doing different reviews at different stages. On one side is this spectrum of how things are done in a space agency. But on the other side is absolute chaos. You need to sort of have a balance where you do have some disciplined way of looking at things, we learned, but at the same time still moving very fast and very nimbly, rather than processes being the be all and end all. And so in Feb of 2021, we had to now redesign about more than half of the satellite. We had to order new components, and there were more restrictions because you already built some satellite. Now your constraints on building things are even more, because they have to fit within a certain volume, they have to fit within certain interfaces, some of which were quite outdated, and so you have to spend extra. So we also realized then we have to do a bunch of different testing. For example, we talked about GNC, and for an imaging satellite, GNC is quite important. So at least for the first few satellites that you're building and launching, you need to see if the sun sensors are actually looking at the sun. Is it finding the sun vector? Is it orienting itself towards there? Is it holding its stability and all of that? And we are able to do that within ISRO's testing facility. So I would say we probably ended up teaching that experienced partner way more about satellites than we ended up learning from there, and that set up the foundation for the team that is there today, that is building our own commercial satellites. We are also a little bit different from most companies because while we do procure some components, we do a bunch of our avionics and our software writing from the ground up, right? For example, we don't go and procure an off-the-shelf onboard computer with software that we can just plug and play with the rest of the stuff, which makes it quite easy. Yes, you can turn around a spacecraft in about 9 to 12 months if you did that. But in our case, we wanted to make sure we are a little bit more vertically integrated. Like, we won't build our own solar panels, we won't build our own reaction wheels, but we will make sure that the entire operational software of the satellite is so optimized. So that's why having that experience with Anand really helped set the tone for how we would do our own constellation in the long run.
Right. So you were more horizontally integrated before, and now you've shifted to not fully vertical integration, but healthy
As much
balance
as
too.
our funding will allow us.
Yeah.
If we had the kind of money that SpaceX does, we would obviously prefer to go all in on verticalization. I do believe that's the best way to keep control on your quality, and especially your cost and your timelines. If you're dependent on vendors who are dependent on vendors, it ends up delaying things. But the idea was always to be as vertically integrated as money and other things would allow us. We started with being a little bit more horizontal and working with partners while still overlooking the systems, because that was what we could do with $700,000 of pre-seed funding. But then once we did the seed, the Series A, the Series B, we have brought in-house certain things that make sense for us in the long term. Yeah.
How has the reducing cost of compute uh, helped Pixxel or just space companies in India? Right, like the cost of compute is so cheap these days. Has that made a real impact and difference to getting a successful company?
We can do a lot more than similar companies elsewhere in the world can do, right? With $8 million of funding, having put 3 satellites in space, I think that's very few companies can claim to do that, of the kind of of the quality of satellites we built and launched. Yes, if you want to build and launch one UCubeSats, you can probably launch 100 of them. But if you're talking about satellites that can actually sell to customers and have a certain quality of imager and all of that, it's very hard with just the first 8 million to actually put all 3 and successfully prove all 3 and start generating revenue from that, which we're able to do. So absolutely, I think being very cost effective and nimble by having some of our operations in India sort of helps that. Of course, as we were talking earlier, we have an office in El Segundo, the Gundo in Los Angeles. We have an office in Bangalore. But the most of the actual manufacturing on our commercial satellites tend to happen in Bangalore, because it's 5 times to 10 times cheaper, right? If I were looking at the same satellite being built here in the US versus in Europe versus in India, I can build it for at least 5 times cheaper overall if you add the bill of materials cost, the labor cost, the testing cost, and just getting it ready. And that is a big difference, because with just Series B raised, we will put up our commercial constellation that can do a daily revisit by next year, which I don't think most companies in the world can do with the same amount of money. And in space, cash is king, because you're spending on expensive hardware, and if one of them fails, you have to replace them. And so the more you can get out of the same amount of cash that you have, the more successful you will be. So I would say just not overspending is common sense, but has definitely helped being based in Bangalore for a lot of the manufacturing.
Yeah. Uh, Being in the Gundo is also a great move, I think. Side note: do you know Karan Taladi of First Resonance?
First resonance, no, no.
Yeah. So the only note I'll tell you, I talked to him on the last episode, and the note I'll share here is that he's making a jacket called the Gundo Gundas, and I'm gonna buy it. So
Yes.
you should
Just
get one when you're here.
just to clarify, we've been in El Segundo since I think more than 3 years now, which is before it was called the Gundo.
Oh, okay. Yeah, yeah. I do agree that this is a new movement uh, in the Gundo, but it's great. I'd love to come see the office someday.
Please. Yeah, yeah.
Check out all the cool work that you guys are doing here. How have investors, venture capital or otherwise, in Pixxel responded to, say, the issue with component qualification failures? Or I think Shakuntala had like a SD card radiation issue, if I'm not
Yes.
mistaken.
Yes.
So how has that environment been in India, and how have people responded there?
I think investors have been quite supportive, actually. I mean, absolutely no complaints. They do ask questions. They do get concerned and anxious when delays happen, because this is generally when a delay happens in space, it's either you can get it turned around very quickly in a few days, or it's something that will take many months, right? And that's not something that you generally see with softwares. You can, why does it take so long? A SaaS software shouldn't take 3 months or 6 months to get it back in order, versus that's not the case with satellites. But I think what we do generally at Pixxel is, we have a quarterly get together with our key investors, and we give them a heads up whenever anything bad happens. I think we just like, hey, here's something that has delayed or something bad has happened, so that they at least have that sense of trust and faith that we'll be upfront with them. And then we just explain why things happen and how things will happen, right? I think you just don't say that it's going to be a 6-month delay, oops, sorry, and then just leave it at that. You have to say why the 6-month delay was, and put it in a way that they can understand. You have to explain, the supply chain of it, that hey, we looked at these 4 vendors, this is the timeline and the lead times, and this is the fastest, but even if it comes, then we have to do these series of things, and then it will take this much time to test. So I think given all of that, they've been quite supportive. I don't think we have ever faced unreasonable opposition to a delay. The delay has always been due to things that I think everyone in the space industry is aware of. Sometimes a supplier is delayed because their supplier is delayed. They are delayed because there's a semiconductor issue, and so you can easily sort of map that out. And then we are also building fairly complex pieces of hardware. These are again, one small thing goes wrong somewhere, you don't know why it has gone wrong, and you have to figure out why that is, and if this works, something else breaks, and then you have to sort of redo that. So it's a very, very complex piece of machine, and they do understand that, and so it's been not too bad, I would say. I've also heard quite nightmarish stories from some other startups where investors didn't really understand that, but not in our case. I think I'm quite lucky and glad to have had the partners that we've had. In the end, I think all you have to do is explain to them why and how, and what the repercussions and implications are. But otherwise, it's fairly smooth sailing.
I feel like a lot of us in this industry are definitely working to bridge the awareness gap that investors have, or more traditional investors and VCs have, where they expect sort of software like timelines on bug fixes, and that's just not the case with spaceflight hardware. I also saw that on Pixxel's board of advisors, there's Jordan Noon. Um,
That's right.
I've certainly learned a lot from Jordan. I went to school with him, we overlapped at USC in our times. He taught me how to lay up my first composite in school.
Awesome.
How did that relationship evolve? And it's personally just very cool for me to see a friend of mine be involved with a company in the place that I come from originally. So
Yeah, no, he's a very chill dude, very cool dude. We initially got introduced by someone, and we had I think Lightspeed. So Lightspeed ended up making the intro to Jordan, and we spoke over a Zoom call initially. And I after the call, I was just like, hey, we have this round closing. In case you want to come on board as a angel investor, we'd love to have you, and love to have your advice, having built relativity. And so he was quite happy to do that, and we got him on board as an angel investor. But mostly after that, it's been more like a a friend, right, who you can reach out to and have conversations around why and how, and how to go about things. We've met in person a few times when I've been here in LA for lunch, for coffee. So he's been pretty helpful in sort of just being very open and frank about how they went about things at Relativity, and what we can learn from there, what to do and what not to do as well. And having someone who's been through that journey is a very, very different kind of advice than from someone who's built some other kind of startup. I mean, yes, you can definitely learn from the other person as well, but just being in this industry gives you battle scars that you otherwise can't get, and it's better to learn from other people's scars than to get your own in most cases. So I think that's where he has been really helpful.
Yeah, it's one small mistake, one small hardware failure can totally kill a company. And we've already seen that with some launch companies, right? It's very expensive. And I'm very glad that the space industry in general is becoming more global, where space is not so much of a nation states, but now private companies are sharing information and trying to again lift all boats on a rising tide. So it's very cool to see. Moving on to the future. So you have a launch coming up next year, right? Is what you said, where
Sometime in the next few months.
and that is multiple birds to get you a daily revisit rate.
Correct. So we're building 6 Fireflies. The Firefly is the name of the first constellation that we will launch, which will be followed by honeybees starting next year, and then hopefully some more in 2026 and 7. But yes, right now we have 6 satellites that we have built that have been tested, that are undergoing final tweaks and optimizations at the facility. These will be the 5-meter hyperspectral birds. And 5-meter obviously doesn't seem like a lot when you've seen 30 centimeter maxar imagery or 10 centimeter albedo imagery that's to come as well. But when you're looking at the number of wavelengths, 150 wavelengths that we'll be able to provide, and then 300 next year, and the amount of spectral detail we'll be able to unearth, I think that's what people are most excited about. We are most excited about. And yes, you rightly mentioned, with just these 6, the first 6 Fireflies, we will have a daily revisit anywhere on the globe. So the swath, the field of view, the constellation geometry, the altitude is designed in such a way that no matter where on the globe, at the equator, again, which is the worst case situation, we'll be able to come back and relook at things at least every 24 hours. And it'll be much, much better as we get closer to the poles, down to just a few hours or so. So that's what the 6 satellites will enable, which means that we are now in fully commercial mode, which means that these 6 satellites will go up, we will start selling data, and hopefully the revenues we generate from that will be enough to sustain us moving forward, and make us EBITDA and cash flow positive, hopefully, and not be dependent on more and more investment.
And I should say that 5 meters is the highest commercially available, will be the highest commercially available resolution. Is that correct?
5-meter will be the highest resolution truly hyperspectral satellites up there. There are a few other satellites that people will claim are 5 meters hyperspectral, but they usually have either 20 wavelengths or 30 wavelengths or so, which is 20 is basically multispectral, and then you go to 30, probably super spectral, which is a little bit between multi and hyper. But when we say hyper, we mean the entire wavelength range, contiguous in nature without a single gap, in very, very minute narrow bands, and all of it at 5 meters. That's what will be truly hyperspectral at 5 meters. The first commercial satellites in the world to have that. Yes.
Yeah, I'm very excited for all of the applications. We of course saw a couple of talks at EO Summit this past year in London. Very excited to see that. But looking even further out into the future, what is your view on the Starship era and what it can do specifically for Pixxel? Well, I built on my day job, I built very large solar arrays at Redwire.
Yeah.
Right. So they're like big 30 plus kilowatt solar arrays, which are certainly meant for large satellites. How is Pixxel factoring the Starship era, and is size truly matter in terms of hyperspectral satellite development?
It does. I think size matters for every kind of imaging satellite. The larger your satellite, the larger your camera can be, and the larger your camera is, the better the resolution will be. I think there will definitely be a little bit of a reset in how people think about satellites and launch costs over the next 5 to 10 years. I don't think that will be immediate, as in, I don't think in the next 2 years people will radically start rethinking their designs. Of course, a few companies are already banking on that. K2 Space, for example, a few blocks from here, is betting on very large satellites. But I think most of the use cases there are commercial satellites, communication satellites, right? What used to um, mainly for the likes of folks that want to provide connectivity to either satellites or direct to home and things like that. Um, Personally, in the case of Pixxel, I don't think it's going to make a big difference over the next 2 to 3 years. But I would say definitely over the next 5 to 10 years, um, given the larger fairing that Starship will have, we can probably build larger volume buses, even though the mass might not be as much, which means we can be more innovative with the kind of cameras that we will build and launch along with other Earth imaging companies. But we also at Pixxel have long-term ambitions around in space exploration and scouting of different planetary bodies, whether that's moon, Mars, the asteroid belt, near Earth objects, and eventually to even mining rigs and stuff like that, robotic mining spacecraft that can help bring material. Right, Redwire I think also is testing out how to manufacture stuff in space, but where do you get the long term material from? You get it from space rather than launch it from Earth. Things like that. So I would say that will definitely be a paradigm change. But I think what I'm most excited about that doesn't really directly pertain to Pixxel is probably how many large habitats and space stations we can actually build and launch. Because look, I think it's great that we are looking at creating you know establishments and habitats on the moon and eventually Mars and all of that. But um, if we really want to go beyond the solar system, at some point in time over the next few decades or centuries, we have to build our own biomes in space. We can't be dependent on planetary biomes. And for that, you have to build generation ships, very large spacecrafts and stuff like that. And you start that by doing habitats in Earth orbit, in lunar orbit, where people can live, work for long extended durations of time. And for that, you need to have radiation shielding. You need to have rotational stuff that can help bring gravity, because you can't be in microgravity for all that duration and so on. So I would say that's probably the biggest change that Starship will hopefully bring and accelerate our advent towards launching larger and larger space stations and therefore habitats for people to work and live long term, but then using that to build generation ships that can hopefully be sent to other solar systems where people live and create newer generations, and they create newer generations for many centuries and so on. So I'd say that's what I'm most excited about. Not directly pertaining to Pixxel, obviously, as of what we do today, but exciting nonetheless.
Yeah. There are so many companies in LA that are doing that, right? Like there's Astroforge looking into mining asteroids. They're building the refineries. It'd be cool to just all of this becomes an ecosystem where Pixxel provides the satellite bus with the camera for Astroforge, and they go mine the asteroids. Or you have Vast building very large space stations with gravity on them. And it's just cool to see all of this coming together. I think a lot of us optimists in the space industry are making that bet. And I think that comes to my next question. We have one or two more here. The people who are successful, in my view, in the space industry are folks that make a contrarian bet. An example is Elon Musk saying that we should reuse rockets. Let's reuse rockets. Why are we not reusing rockets? Everybody laughed at him. And then SpaceX did it, and God knows what their margins are on launches, right? What is you're clearly taking a contrarian bet with Pixxel, but I'm just curious, what is your contrarian bet in the industry as a whole?
I don't think it's very contrarian anymore, but I think the last couple of decades have been towards building smaller and smaller stuff to launch to space, and we just talked about how Starship will change that. So I think the contrarian bet people should be taking is, how do you factor in building larger and larger buses, because the costs for those will go down, not just building them but especially launching them. So rather than figuring out how to cram as much into a small kind of CubeSat or eventually other small satellites, launch humongous Hubble Space Telescope sized satellites, turn them towards the Earth, and see in a detail that you would not be able to see otherwise. So, I mean, I think there's a decent number of people in the space sector, but if you look at the overall industry, I would probably still say it's one of the contrarian things. I can't think of anything else, so I'll stick with that.
Yeah. Okay. That's a good answer. Now the next one is from your own website. Um, do you have you found an answer to this question? Is the universe actually a simulation?
No, I don't
And
think
can
so.
we know?
I don't think so. I don't think we can know today. I will continue to hold out hope that at some point we can. There's a variety of different books that talk about it. Obviously, one is the Fermi. When you're talking about Fermi paradox, why can't we see others? Are we in a simulation, right? But I think I was reading this book, The Beginning of Infinity by David Deutsch, and there's also The Fabric of Reality he has written, where he talks about a quantum Turing machine, basically, which is something that you can use the quantum um, the weird properties of the quantum realm to build computers that can simulate physical processes, and eventually we can likely get so good over the next few decades, if not centuries, that we can build something that can simulate entire universal physical processes. And at a certain point, if a civilization can get big enough or large enough or technically advanced enough that they can tap into entire stars and other power sources to leverage all of that into simulating something, I
That
don't
type
see.
1, type 2, is that the type
Yeah, I would say
civilizations? Yeah.
probably type 1, where anyone can leverage the entire power of a solar system. But even type 2, maybe you don't even need to get there. Maybe if you can figure out how to efficiently build a quantum emulator that can build a simulator where you can simulate consciousness through physical processes using a quantum computer, that might increase the probability that, hey, if we can do this, what's stopping another dimension from sort of creating this simulation? And is it turtles all the way down, or where does it stop? Good to think. Can anyone say with a assurance? I don't think so, but it's just cool to think about.
Cool. Yeah. All right. My final question to you is, it's probably the hardest one. What is your favorite chart place in Bangalore?
Wow. Ooh. I mean, I'll probably go with the safe answer, CTR, the Central Tiffin Rooms for the masala dosa. I think if you go at like 7 a.m. in the morning, you might get lucky and get a table to you. And just that
Right.
crispy, hard dosa in the morning is probably the best breakfast one can have.
Such a good breakfast. For me, I have to go with masala puri.
Okay.
It's just such a unique Bangalore thing.
Yep.
But it was such a pleasure talking to you. I wish Pixxel all the success. It's definitely very close to my heart. You're my first guest from Bangalore. So it's like an extra special one for me. So thank
Awesome.
you again for being on.
No, thank you for having me. Thank you very much. And it's been a fun conversation.
Thanks for watching this episode with Awais. Stay tuned for more episodes.